Okay, today I'm going to look at some exoplanets, and the exoplanet that we're going to look at today is 51 Pegasi b. So what I'm going to do, and then we're going to try to replicate 51 Pegasi b as it looks in space and how it orbits its star. So what I'm going to do here is open up a new empty simulation. And first I'm going to put the star. So there is no 51 Pegasi b that I can see listed in their list of stars. So we're going to have to go with sort of make our own and go with the closest that we can. And actually the closest star is our own sun. 51 Pegasi, which is a star in the constellation of Pegasus, is a yellow main sequence star, and it is spectral type G2, just like our sun. So that's what I'm going to put here in the center. Now I'm going to have to modify it just a little bit. The mass is a little bit higher. It's going to be 1.11, the mass of the sun. So it's has a little bit more mass, as it is a little bit older than our sun. And let's see, the radius. As you can see, the radius here is a little bit higher. If it was the sun, it would be 1.0. So this is a little bit higher. Actually, it is a 1.237 radius of the sun. And its surface temperature is a little bit lower. So we're going to lower that just a little bit, just a little bit. There. That's the heat of the 51 Pegasi. And it's a little bit older than the sun. And so I'm going to rename this to 51 Pegasi. Voila, there we go. So now I'm ready to add its most famous planet. This was one of the first exoplanets ever found, 51 Pegasi b, also known as 51 Peg b for short. It was discovered in 1995 by a French in France, and it's a huge planet, and I think that's why it was one of the first found. So let's add it. It's got an orbit that's a little bit closer to its star than Mercury. Mercury at its most is about 70. So I found that about there it would probably be the best. So let me click on that, make sure. As you can see, it's very hot. It looks different from what it does in its picture. Let me make sure I have the orbit. I almost have it perfect. So it takes 4 days to orbit its star. So I just have to adjust it just a little bit. As you can see, the orbit here just has to move a little bit. And surface temperature is going to be, let's see if I can change that to Kelvin. So it's not hot enough yet. It should be about almost the same temperature as the star. And as you can see, it is heating up. Now, so this is what's called like a hot Jupiter. It's a gas giant that orbits very close to the star, unlike our gas giants in our solar systems that orbit a little bit further away from the star. So there it is, 51 Peg B in its orbit around its star, 51 Pegasi. Let's look at this planet. You see it's still hot. Let's see if I put Jupiter. You can kind of see it's a little bit bigger than Jupiter. So imagine if Jupiter was orbiting at this distance from the sun. If I were to add Jupiter here, it would look very similar to 51 Peg B. It would just be a little bit smaller. Here it is in comparison to Earth. Look how huge it is next to Earth. So if our solar system had such a large gas giant, we probably would not have the Earth we have. And let's see its composition. I wonder if this will be changed because they did find a little bit of water vapor recently. Let's see if I add just a little bit. See, it's so hot that it would just turn to plasma. It really didn't do much to it. The surface temperature is still a little low. It should be higher than this. There we go. Well, it's not letting me do it. It's still not letting me do it. So I might have done something a little off because it should be higher. Let's see if I put that into Kelvin. Interesting that its albedo is 0.01. I had it perfect earlier, but right now it's not. So maybe if I adjust the time on it. Well, it is still going crazy. I actually lost a little bit of mass. So there you have it. That's how you play Universe Sandbox 2.